So today we'll start with the construction of pseudo random objects. Okay, that is one of the important topic in cryptography. So before jumping into pseudo random objects, okay, so let me first clear you the things about what is a random object. What is a randomness? Okay, so the term is called randomness. NER. So, what is a randomness? Can anyone of you tell me what is random numbers? What is randomness in cryptography? About if in between you are not, if my screen is not visible, please do tell me. Okay, and if in between you think that my voice is not audible, please do tell me that. Okay, so
All
like before going to this pseudo random objects generator, first we have to clear the things like what is randomness, what are random numbers. Okay, so what are random numbers? Can anyone of you tell me random numbers क्या होते हैं? Like what are random numbers? What is random number generators? Okay, no problem. So let's start with a random number. Like what is a random number? Suppose there is a one number Rn, that is random number. अभी random number कब होगा? Like when the Rn we will call Rn is equal to a random number. Okay, if only two conditions. Okay, if only a generated number fulfill the two conditions, that are randomness and randomness and unpredictability. Okay, so now suppose I have any mathematical equation. Let any mathematical equation. Okay, suppose I have a plus b equals to a plus b whole square equals to a square plus b square plus 2ab. Okay, I'm giving you a very basic example. Okay, don't correlate this mathematical equation like हाँ यही कुछ होगा, ऐसा कुछ नहीं है. I'm just giving you a one example. Okay, so now I'm talking about random numbers. Okay, the random numbers क्या होते हैं? ठीक है, whenever, okay, whenever any mathematical equation, whenever any mathematical equation gives us these two things, that is randomness and unpredictability. Okay, whenever any mathematical equation give us a number in numbers in the form of like the numbers which are random and which are unpredictable. Okay, so that numbers are called random number. For example, I wrote one equation here: a plus b whole square equals to a square plus b square plus 2ab. Okay, this is a very basic equation of mathematics, and we are putting any value of a and b. Okay, and we are getting the result. We are getting a result by by putting the values in this equation. Any number, any random number, any unpredictable output. Okay, so that numbers are called random numbers. First we have, so this is the equation. Please don't over. Hello.
Hello. Sir, if some equation is considered, then it will automatically generate a fixed number. It is not a random number. If I will consider y equals to x plus 1, then
Sir,
it is also producing a fixed type of numbers.
I'm
So how it will be random?
I'm totally agree with your query, like if we are giving any equation, like this is an equation, okay, a plus b whole square equals to a square plus b square plus 2ab, okay, this is the equation which we have, okay. But if we put in any value and we will get the answer, okay, we know that we will get this particular what answer, we will get a particular value, so that is not a random, fine. But the thing is that I am just covering the point of what is random number in a very basic way. I'm not saying it, okay, like we have an equation, like this is an equation is given, okay, and we are putting the value of a and b and we are getting the responses or answers. The only thing what I want to explain you guys are, like before jumping into the pseudo random number generators, like what are the random numbers. As the thing is this random number, as the name suggests, like random number, like what is randomness, that is automatically without, we don't know, suppose we have an an array where we have 100 elements, okay, and we want to, and computer wants to pick any number from that particular array, like we have an array of 100 and randomly computer chooses any number like 75, 76, 77, okay, so that is a random number. But behind of choosing that particular randomness, behind of choosing that particular random number, there is some mathematical equations are evolving, mathematical algorithms are involving. I'm not stating that like this is the equation whatsoever I wrote here is an equation we are getting, we will get any random number from this. I'm just giving an example like how it works, so that this is a very basic equation that we know, like a plus b whole square is equal to a square plus b square plus 2ab, okay. We will get any number that we will put a value, we will get the number. That is a thing that we will getting a number. But in terms of computer networks, okay, in terms of data structure, in terms of this cryptography, if we want to generate any number, we have to do some mathematical algorithms, we have to perform some mathematical equations on that. So this is just a basic, I'm giving a basic point like how we will get a random numbers. It's not like that, okay, we there is one static equation and then we will get a you know the random numbers. Is it okay?
Yes, sir. Fine.
Okay. So the basic thing is that whenever we have any random numbers, okay, so only two conditions. There will be the two condition whenever we are getting any number, okay, and if that particular number is satisfying these two conditions, that is randomness and unpredictability. So this n is equals to Rn, that is called random number. So now the thing is that the very first point is, now if n, if I'm getting an n, okay, and the n is satisfying these two things, randomness and unpredictability, then that n is what, random number, Rn. That's it, okay. So random number क्या होता है हमारे पास, whenever we are getting any number in the whenever we are getting any number and that number is random, we don't know what kind of random, like what kind of number it will be, and that number is totally unpredictable, we don't even know, like okay, like this will be the number, we don't even make a guess, so that is called a random number. So now the thing is that, so the very first point is randomness. So how we can say that the number whatsoever we chose is a random? So how we can say that, okay, the n is satisfying this condition randomness, okay. So for that we have to do some basic things by algorithm, that is uniform distribution and independence. So now if I'm having a number n and that number is satisfying this particular case, that is randomness, okay. But now the thing is that when when we are able to say that this particular n is random, getting my point, like what I want to say, n is a number, ठीक है, and we will call n a random number when two conditions, only two condition will get satisfied, that is randomness and unpredictability, okay. ये तो हमने prove कर दिया, if n is if if x is giving n, okay, if x some input is giving, this is input, okay, if this input is giving some n, okay, and if this n is random, first case, or unpredictable, then we will call this n is random number. Fine. So this is the basic funda of cryptography when we are dealing with the numbers. Now the thing is that when a particular number is random, when we will call that particular n is, this n is random. So for that there are two terminologies that you might heard, definitely, that is uniform distribution and independence. So can any one of you please tell me like what is uniform distribution? Please make this session as a not a one to many. It should be like one to one or one to many, many to one. It's not. Please don't make it like only I have to speak and no response from you guys. Please make it interactable.
Independence. Independence means it is random, and uniform distribution means will be specified in terms of polynomial structure, and it is uniform.
Uniform distribution. You are saying that in terms of polynomials.
No, not necessarily
Sure.
polynomial. The difference will be same.
Okay.
May be defined in terms of polynomial, but if the difference is uniform, then it will be uniform distribution.
Okay. Can we say that uniform distribution like frequency? Can we use this
Yes, yes,
term? Okay.
yes, yes,
Frequency of occurrence can I use
yes.
of each number? Suppose I'm getting a number. Okay. Let me write first. Frequency of occurrence of each number should be what? Same or different?
Same.
Is it okay?
And
Whenever
independence, it is different.
yes, I'm talking about right now uniform distribution. Okay. So now you please tell me like whatsoever I written here, frequency of occurrence of each number should be same. Is it okay? This justified. This justifies like this is a uniform distribution. Yes, this justifies. Okay, if we are getting, if we are getting any numbers like suppose x, y, z whatsoever. Okay, and the frequency of occurrence of each number, frequency of occurrence of each number in that particular string of number is same, then that is called a uniform distribution. Okay, and one more thing is we have independence. Okay, that is independence. We have two terms. What is one is dependent and the second one is independent. So what is independence here? Please tell me like okay, uniform distribution is like frequency of occurrence of each number should be same. So now what is independence?
Frequency of occurrence will be different, not
Yes,
uniform.
it not uniform. Nice. Okay, fine. So as I told you earlier, this is my input, and this input is giving me some n. And how I'm getting this n? By some mathematical equations. Okay, and now when if n is satisfying this randomness, or what is the second one? One is randomness and second one is unpredictability. Unpredictability. Then this n is then this n is a random number. Okay, so now okay, this is satisfying this randomness. Now how we can say the number is random? How we can say the number is a random number? So for that there are two conditions, that is generated number must satisfy the condition of uniform distribution, and independence. Okay, so this is in the term of randomness. Now, unpredictability. This is a very basic term, that is unpredictability. Predictability is what? Predictability is what? Like we know after 2 years what will be our age. That is a predictable thing. And what is unpredictability? That we don't know how much we will live. Okay, this is the thing. This is the right definition. What is unpredictability and what is predictability? So same in the case of numbers. Like what is unpredictability? Here, unpredictability is, you can say, like each random number is independent of each others. Okay, so whenever we're getting n, and if n is uniform distributed, if n is independent, and if n is, you know, the number n is independent of other numbers, then that particular n is Rn, and that is called random number. So this is the basic funda of random numbers, a very basic, terminology in cryptography. Whenever we are dealing with the RSA algorithms, whenever we are dealing with the AES, whenever we are dealing with many cryptographical, like uh, private and key cipher algorithm, so we have to use this kind of numbers. Okay, so now this is our random numbers, like how we are getting the random numbers, how, like what are the conditions which satisfy that particular thing is a random number. Okay, so now the next thing is where these random numbers are useful, like where we, like, okay, I'm getting a number, like what is the use of random numbers? Okay, I am having a normal number n, and one side I am having a random number Rn. So now what is a, like what are the various scenarios where, you know these random numbers are useful? So the very first one is these are the very basic, topics, and I'm expecting that you know all these, like key distribution, session key generation, generation of keys for RSA, and many more. Okay, so these are the basic things, like where we need Rn, random numbers. Okay, so I think before jumping into pseudo random generator, like pseudo random numbers, first we should know, like what are the random numbers and how we will get the random numbers, and what are the conditions, and that what are the conditions that are required for saying that that particular number is random number. Okay, so I think any doubt for this, like this is a very basic thing, apart, like this is just basic of the topic that we will cover now. We will cover two algorithms, so this is a very basic thing. Any doubt in this? I'm able to clear you, like what are random numbers? Hello, am I audible?
Yes, sir, audible.
Is it okay? Okay, so now let's start with pseudo ram pseudo random number generator. Like what is pseudo random number generator? Pseudo random number generator, which is also known as PRNG, okay, a short form of this, refers to an algorithm that uses mathematical formulas to produce sequence of random numbers. That we will discuss, that we will know what kind of algorithms and how they work and what are the mathematics behind that. Okay, it generates a sequence numbers approximating the properties of random numbers. It starts from an arbitrary starting state using a seed state, that we will see, like what is seed state. Many numbers are generated in a short time and can also be reproduced later if the starting point in the sequence is known. Hence, the number are deterministic and efficient. So now here, like the topic is like how to generate a pseudo number, how to construct a pseudo object, how we can do these things. So before, no, you want to construct a pseudo random number, you must know like what are the random numbers that I told you, like how, like what numbers are random numbers and how we will get that particular numbers. Okay, so this is the basic things like whatsoever I read written here. I will share the PPT slides. Okay, so the main funda is I just want to deliver to you guys, to you guys like how it works. Okay, what are the algorithms and what is the basic mathematics required for that. Okay, so this is the second slide, like why do we need PRNG? With the advent of computers, programmer recognize the need for a means of introducing randomness into a computer program. It is difficult to get a computer to do something by chance, as computer follows the given instruction blindly and is therefore completely predictable. It is not possible to generate truly random numbers from deterministic things like computers. So PRNG is a technique that developed to generate a random number using computer. So now, why do we need PRNG? Okay, so it is written, like it is proved that like it is not possible to generate a truly random numbers from deterministic things like computers. So we use a techniques, PRNG techniques, to develop or to generate a random numbers using a computer. So now the thing is that like PRNG techniques. Now, how what are the PRNG techniques and how they work? Okay, so in this PRNG, what we what we will have is we have two algorithms. The very first one is LCG algorithm, that is also known as linear uh, generator, and the second one is BBS, that is Blum 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 Shub. So how PRNG works, how pseudo random number generators, how to construct a pseudo random numbers, how to construct a pseudo random object in cryptography in computers. So we have two techniques. The very first one and the very important one is LSG. Okay, that is linear
Hello,
generator. And the second, yes,
sir. Whether object and numbers are same?
yes, the object and number are same. So we are talking about, hello,
Hello.
yes, objects and number are same here. We are not constructing any any particular object here. Because of the pseudo random is like we will construct the numbers in the form of string. Okay.
So how object will be considered? Means random. Definitely, all are pseudo random numbers or random numbers normally.
That I will tell you.
Whether we can consider this as an object.
That I will tell you after completing of this algorithm, LSG and BBS. Okay.
Okay.
Yeah, you will get to know like what is going on, like what how we are getting the objects and how we are getting the numbers. Fine. So the very first algorithm is LCG. So this LCG is used to generate pseudo numbers, and this is introduced by the scientist Lehmer, and it works on four parametric values. Okay. Am I audible to you, sir? Like, can I get your name? Like,
Yes, sir. Audible.
what is your name?
Yes, sir. Audible. PC Sethi.
Okay, fine. Four parametrical. So, have you heard about this algorithm before? LCG. Like, what is LCG? Is this
No,
the
sir.
first? Okay, fine. So let me complete it first. Then you will then you will get to know about what is object and the numbers, pseudo numbers and pseudo random objects. Okay. So this is the algorithm LCG. This is a very important algorithm. So considering that you all guys have a doctoral degree, I will not jump into the very basic thing like what is pseudo, what is who is lemma and all. I'm totally jumping into the algorithms now. Okay, so now we have four parametric values in this algorithm. Whenever we have to use LCG, okay, we need four parametrical values. So this is a very important thing. Okay, please, if you want to, please pay attention here. Okay, so the very first one is M. Fine. Very first one is M. Second parametric value is A. Third is C. And the last one is X naught. So now, what is M? Any guesses? What will be if you are, in cryptography? M is a very basic term. Apart, I am from deep learning and this machine
It's
learning.
message.
What is M?
Message.
It is modulus in math. I'm talking about
Okay.
parametric values here.
Okay. Okay.
Yes, this is modulus. Here A is multiplier, C is increment, and X naught is the starting value. Okay, so now the conditions, the values. So whenever we have to put a value of modulus m, so it must be m is greater than 0. We cannot put the value of modulus 0, basic math. We cannot put modulus minus 1 here in this algorithm. Whenever we are demonstrating or we are executing this algorithm, we need the value of what? We need the value of modulus greater than what? 0. Okay. Then we have the second thing is we have here multiplier. So the range of multiplier, any guesses? Like what will be the range of multiplier? Okay, no problem. That is 0 is what? A is what? What is this? 0 is less than A and A is less than M. Okay. Increment 0 less than equals to C less than equal to M. So here C is increment, here M is modulus, here in the second equation A is multiplier and M is or modulus, and starting value is 0 is less than X naught is less than M. So these are the generic equations whatsoever written here. These are the generic equation whenever we are dealing with this algorithm. So we have to prove we have to set our values in such a way that these equations get satisfied. Okay. So now the thing is that we are using LCG, and in LCG we need to generate a pseudo numbers. Like the thing is, from a given string, we want to generate a pseudo number. We want to generate a pseudo object, or you can say a pseudo number. Pseudo object is a fancy word. If you are searching of many papers in Google Scholar, and if you want to search the if any topic in a book, you will get the pseudo numbers. Okay, mostly scientists are dealing with the pseudo numbers. Fine. So now, so this is the four parametric values that I have, and I have to use these four parametric values here in an equation. So now the equation is the very important one is equation is this: a x naught plus c. So this is my equation. That is equation 1. So by using this equation, I'll get what? I'll get pseudo random numbers. And all these parametric values, that is M, this is modulus, okay, A is multiplier, C is increment, X naught is starting value. By putting all these values, I will get next number. Next what? Next pseudo number. Okay. I think the equation is very simple, and we'll do some basic numerical to generate a pseudo random. Then you will easily get to know like what how it works and what are we getting. Okay. Suppose I am having given A equals to 7, C equals to M equals to 32, and my X naught equals to 1. and to I want to get the pseudo random numbers from range 1 to 32. Okay, so these are the parametrical values I have. I have a equals to 7, my is 0, and my mod is 32, and my initial point is starting point is 1. And what I want a pseudo random number ranging from 1 to 32. So by how I will get that? Okay, like how I will get that, and what is the basic math behind that is, now the thing is that I want to get a range from 1 to 32. Fine. So for each number, for each value, like for x1, x2, x3, x4, x5, no, x6 till x32, I have to find the number. Okay, but in between, suppose if I am getting x4 here 7, fine, and again x5 I am getting 7. Okay, or you can say in x5 I am getting 16. I'm giving you one basic example, and in x6 I'm getting 7. So here my two terms like x6 and x4 are same. They are giving a same result. So in whenever I'm getting a in between the same result of any sequence, any uh, you know um, any sequence number, so at that time my algorithm will halt. Okay, so that we will see by doing this one example. That's not I think it will confuse you. Wait a second. So let's start. So this is the given a equals to 7, c is 0, m 32, x naught is 1, and I want to generate a random number. I want to generate a pseudo random number ranging from 1 to 32. So for that, so ranging from 1 to 32. So first I have to calculate x1. So as per the equation given here, my equation is what? A x naught plus c into mod m. Okay. Now I'm putting my given values here, that is 7 into 1 plus 0 because c is 0, and my mod m, this is mod m, so my mod 32. So by solving this I'll get 7 mod 7. I will get x1 equals to 7. Fine. So same, now I have to calculate what? X2. So in this case, you guys please, here you can see that x naught is 1. That is my previous value. Now I'm getting x1 is 7. And now I have to calculate x2. So for that, I have to use 7 into my previous value, that is 7. Okay. Plus same. Increment is same. Okay. Mod 32. That I will get 49 mod. What is 49 mod 32? Can anyone please tell me? क्या होगा ये? What it will be? 49 mod 32. It is 17.
17.
Yeah. Fine. Are you getting now? Like how I'm getting x1? Is it clear? How we get x1?
Yes, yes.
You're, is it clear how am I getting x2?
Yes.
I am just in x2. I'm doing what? I'm just changing the number. I'm just changing this value. Why? Because as per the given algorithm, as per the given equation, I have to use the previous value of the sequential number. Fine. Now in the case of x3, same. I will put the values. Okay. Here I will use 17. Okay. Plus 0 mod 32, and I'll get 119 mod 30, that is equal to 23. Okay, now again I will do it for x4. Please do it by yourself also if you want to know like how it will work. So here the thing is 7 into 23 plus 0 and mod 32, that is equal to 7, that is equal to 1. Okay, you please check. And then x5, that is equal to 7 into 1 plus 0 mod 32, and that is equals to 7. So now In this case, I'm getting x1 equals to 7 and x5 equals to 7. Okay, so my x1 is 7, my x5 is 7, and if I put the value x the give the output of x5 in x6, I will get what? X2. Fine. Then whole process will repeat. Again I will get 7, again I will get the same numbers of like I will get 17, I will get 23, I will get 1, and all kind of all same numbers. So now, as per these algorithms, whenever at any point we get the same numbers, okay, same random pseudo random numbers from in any iteration, so we have to stop. Okay, so we will stop here and we will take the previous values. Like now here at 7 I'll stop. Okay, so the range 1 to 32 will be 7, 17, 23, 1. So this will be the pseudo random number generate the pseudo random number range between 1 to 32. Getting my point how I'm getting this? Okay, इसमें हुआ कुछ नहीं है, nothing is happened here. Now look again. We are using four mathematical terms. That is a basic math. Whenever it's a very basic terms of cryptography. When we do with the when we start the initial chapter of cryptography, we will know like how this private key encryption decryption works, and these all are that terms like increment, multiplier, modulus. Okay, these all are the mathematical terms which is given by Lammer. Okay, so now, and the formula is xn plus 1 equals to ax naught plus c mod m. Okay. So now, what is xn plus 1 here? What is x naught in this formula? X naught is the starting value. Okay. X naught is the starting value, initial value, and xn plus 1 will give me the n plus 1, that is starting value plus 1, that is next value to the starting value. Okay, it will give the result of that particular value. So the formula is xn plus 1 is equal to ax naught plus c into mod m. Fine. And now I have to put the values, not me. The computers have to put the values. Okay. So this is the thing. Like this is a simple example, like how we will generate a pseudo random number if the following things are given to us. If I'm okay, we know that the multiplier is 7. We need the value of multiplier 7. We need the increment 0. Okay, because as per the values we can use this increment value to 0. Okay, and we have mod is 32. Okay, so we cannot increment the value of c more than 32. Okay, we can put any like, okay, the value of mod is given in this numerical is 32. Then we have the starting value, like from where we have to start, that is 1, that is given. We can start it from 2 also, that's not a problem. And if we want to calculate the range from 1 to 32, then we have to start from 2. Like we have to write here, instead of x naught we have to write what? 2. Fine. Then we put the
Hello.
values. And am I audible?
Yes, sir, audible. A question. Sir, can we predict some equation so that number of random numbers to be generated could be fixed? Here, four random numbers are generated.
Okay.
So, can we specify some equation so that 10 or 100 random numbers could be generated? Whether it is predictable or not?
We
Just like in case of simulation, we are specifying in functions that I need 100 random numbers within this range.
like you are saying that, fine, okay, if you are using this particular algorithm, if you are using LCG, okay, if you are using LCG for generating a random numbers, and you are saying that I want to generate 100 random, like your question is like, if I'm here we have range 1 to 32. Okay, but you are saying that you want to generate a more than four random numbers. Is it? Is this your question?
Yes, sir.
So as per this algorithm, it is not possible. You cannot generate more
Okay.
numbers. Yes, as per this algorithm. But yes, by using blum blum shub algorithm, or you can by using more advanced algorithm, yes, you can generate that particular numbers. Okay, but by using by in LCG we cannot generate. We have to stop when when we are getting the same numbers. We have to stop our iteration. That's it. This is about LCG. We cannot generate more than we cannot generate the desired numbers like like sport. Okay, fine. I have a I am having a range like 1 to 50, and my algorithm, the proven algorithm, is giving me the value, the random values of range 10 numbers. Okay, and but I don't want 10, I want 25. So by using LCG it is not possible, but yeah, by using more advanced algorithms it is possible. But using this algorithm, it is not possible. You will get only the desired algorithm whenever till your iteration of the algorithm will stop. Okay, at any point of time. If this iteration is getting stopped at 15, after 15, then yes, you will get only a 15 random numbers, not more than pseudo random numbers, not more than that particular uh, uh, that particular given output by the algorithm. Okay.
Okay, fine.
Yeah. So you're getting the basic math behind that, now, like what is happening, like what is the basic equation and till what iteration it will go, and how we will
Yes, sir.
solve.
Got.
So is it possible to you? So my question to you now is it possible to you to construct a algorithm for this? Like what will be the algo? Can you please help me out?
Yes. Whatever
Yes.
four parameters specified, it has to be initialized, and
Okay.
one iteration to be specified until the same element will not iterate. And the equation will be xn plus 1 equals to a into xn plus c, some whatever equation specified.
Equation
It
is
is not
x.
x0. It is not
Yeah.
x0. It will be xn, so that
Yes.
xn plus 1 could be derived.
Yes. X naught is not zero. It's not, which is also
It is
given term.
it is xn. Yes.
Yes, xn plus c. Whatsoever I written up na, this is I use not, not zero. X naught. But
But
okay.
it will be
This,
xn.
this is xn plus c into mod m. So this is the equation. Okay. And whenever I'm getting the value of, can we write like this, xn minus 1 equals to, how to write? I want to write like my x4 is 7 and my x6 is 7. Okay, if I want to write this in my algorithm way, so what is like how to write this?
And while xn plus 1 is not equals to xn, do the iteration.
While xn plus
Plus
1
1 is not equals to xn.
is is not equal to xn, do
Do the iteration, whatever xn plus 1 equals to xn plus c.
do iteration 3, else
Else, go outside. It is not needed. Else is not needed. Because
not x,
while else is not needed. Because condition is false, it will automatically go outside the loop.
and then what it will print?
It need to print xn value, no, xn plus 1 value.
Return
The
from
print operation will be within the while loop. Means do the iteration, yes.
okay.
Xn plus 1 value.
So this is all about the working of LCG. Okay. So now after LCG, there is one more algorithm which we use, that is BBS, which is known as Blum Blum Shub algorithm. So this algorithm is a bit trickier. Okay, so please pay attention here. So now in BBS algorithm, what we do in BBS, the very first step is we have to choose. I'm just jumping into algorithm, okay? Because from this you will easily know like what is happening. I'm not going to the theory part, like what is blum blum schlub, who is blum blum, who invented this and it was invented. Okay, I'm leaving this. So this, the very first step is PQ. That is a first we have to choose a large prime numbers. The very first thing given in this algorithm is we have to choose P and Q two prime numbers. Okay, prime number in such a way that in such a way that if we divide P and Q, if P and Q individually by 4, it will give remainder value 3. Okay, so the very first and trickier step of this algorithm is we have to choose two prime numbers P and Q. Okay, we have to choose two prime numbers P and Q, and that prime number should satisfy this following condition, that is whenever the prime number, if that particular prime number, suppose if p, if we divide p from 4, it will give us a remainder 3. Okay, if we divide q from 4, it will give us remainder 3. And suppose if I'm choosing any prime number, okay, here, and I'm dividing that prime number from 4 and it is giving me the remainder 2, 1, 5, whatsoever, then we will not conclude that particular value of P and Q in this algorithm. So this is the most tricky and basic step of this algorithm. Okay, first we have to choose two prime numbers P and Q in such a way that individually, if we divide P from 4, it will give us a remainder 3, and if we divide Q from 4, it will give us a remainder 3. Okay, so this is the thing, or you can write as like P is equal to Q is equal to 3 mod 4. So now second thing is we have to calculate the value of n here in this algorithm. We have to calculate n. Now what is n? That I will tell you. This is a simple number. We have to calculate value n, that is equals to p into q. Okay, first we will choose the value p and q. Okay, we will choose p and q in such a way that they are two random numbers p's, and those particular individual random numbers, whenever we divide that numbers with 4, we will get the remainder 3. Fine. Then after we will get a value of n, that is a number value n which is equals to p into q. Then we have to calculate s. Okay, now s is here is some random number which is relatively prime to n. Okay, which is a relatively prime number to n. Okay, this is a basic math. We will get to know it in more detail when we will solve the equations. Then we have this x naught h. So now in the next step, fourth step, we have to use s square mod n. Dr. Sethi, you are there na?
Yes, sir.
Everything is going well now. You are able to see, because I'm finding you here
Yes.
more active. Okay.
Yes.
Yeah. So we have to choose two prime numbers P and Q in such a way that whenever we divide individually one any P and Q with 4 only, not 5, 6, only with 4, we will need, if we are getting random number 3, then okay, we have to choose P and Q. Then after we will start this algorithm. Okay, else we will not. We have to choose the number. This is up to us, like what value we are choosing. Then we will get n, we will get s, then we will get x naught. Okay, and x naught is s square mod n. Then for I equals to 1 to k, where k equals to number of random numbers, sixth xi equals to xi minus 1 square mod n. This is our second sixth step. And the seventh one is bi equals to xi mod 2. I know this will look like a more very trickier and very confusing one, but by solving one numerical, we will easily get to know what is happening. Okay, so now this is given here that we have to choose two prime numbers p and q in such a way that if we divide any single prime number with 4, p or q, we will get the remainder 3. Okay, so let's start with an algorithm. I'm choosing two prime numbers, that is p. I choose p equals to 7 and q equals to 11. Reason so, whenever I will divide p from 4 and q from 11, I will get the remainder value equals to 3. So that satisfy my first step of this algorithm. Okay, is it okay, Dr. Sethi?
Yes, fine.
Yeah. Now the second thing is we have to calculate the number n, that is equals to p into q, that is 77. Now third is s. So in this case s, we need to calculate, we need any relatively prime number. Randomly we need any relatively prime number which is not equal to 7 or 11. Okay, which is not equal to 7 and 11. We can choose any, so I'm choosing 12. Okay, and then after, in the fourth case, I'm getting the value of x naught, that is my very initial value of x. So that is equal to s square mod n. So basically here n is a mod value. Basically here we in this whole, no, in this whole equation, whole step, like whole algorithm, starting from the step 4, the value of mod is not given. Generally, in this the previous algorithm, the value of mod is given, but here it is not given. So we are taking it from n. Okay, so here we use the value of n. So now the equation is s square mod n, that is s square mod n, and here s is my 12 square mod 77, and this is equal to 125. This is equal to 67. Okay, so now I got the value of what, x naught. Now the fifth step is for I equals to 1 to n, I'll get k equals to number of parameter, where k is number of random numbers. K equals to number of random numbers. So now, what we will do, we will start our iteration. I'll get the value of x naught here, 67. Now I will get the value of x1 by putting this value 67 square mod 77, so which is nearly equals to 23. Then if I'm getting x1, I have to get b1, and b1 is x1 mod 2, that is equals to 23 mod 2, which is equals to 1. So now for x1 I'm getting, now for x2 the same thing I will get, do x1 square mod 77, that is equals to 23 square mod 77, which is equals to 67. And again same, I will do it for b1, sorry, for b2. Okay, so I have to put the values of x2 mod 2, that is 67 mod 2. So this whole process, okay, this whole process, so this whole process, this whole iteration will go till I'm getting the value of any particular sequence number. If I'm getting, suppose, same thing, if I'm getting x6, x7 equals to x9, so at that case I have to stop this particular algorithms, and I will get the value of what, I will get the value of the particular generated random number. So this is how this BBS algorithm works. So basically in BBS algorithms, the very basic step is we have to use prime numbers P and Q, any prime numbers, and that prime numbers, if we divide a particular prime number from any value of 4 or 3, from 4, we will get, if we are getting the remainder 3, then am I audible? Hello.
Yes, audible.
So hello.
Sir, you are audible.
So this is about the BBC algorithm. So BBS. So we, what we do is we will take the prime numbers and, can you please mute unmuted?
Punam Savale.
Hello.
Punam Savale, mic is on.
I don't know whose mic is on. What's going on? Dr. City, is it clear to you? This algorithm is clear to you?
Yes.
So this is the thing, like how
But
to. Yeah.
total number of random number generation could not be predictable. It is still depends on the number of iteration
It
where
depends.
it will be
Yes.
terminating.
No, the thing is that now there are advanced algorithms that even I don't know, because what are these? Because my field is deep learning and machine learning. So this is a topic which I can present to the students of different universities. So yes, by using this algorithm, we will just get the numbers, predicted numbers, but we don't know how much predicted numbers we
But
will get.
how different softwares use this random function? I means how then random numbers are automatically generated. Whether some such type of algorithms must be implemented, I think, to generate this type of numbers.
We actually, the thing is that, okay, suppose now I'm giving a very, example of very real time example. You are doing uh, okay, fine. Have you heard about how OTP works? Is it a random number for you, OTP? Can it be same or different?
Yes, it is also OTP. It is also a random number, and it is specified with some timestamp value so that it will be expired.
Okay. So, do you know how OTP algorithm works? Like how, what is token code, and what is authentication manager, how it calculated and all?
Yes,
Have you heard about the working of this OTPs?
yes.
We use some active IDs. We use some encryptions to, generate OTP numbers and all. Basically, I'm getting your question. Your question is like that. Like still, it is not. predictable how many random numbers we will get. Is it?
Yes.
But
That
if
is the main point because if the numbers will not be random, then the security will not be achieved. So it should be pure random. And could we predict those random numbers in some form so
we can,
that the security can be identified? Because in most of the algorithm cases, we are directly using tools to generate these random numbers, and we are using those random numbers for implementation. So,
okay,
can we predict those random numbers? That is my question.
manually we cannot predict that random numbers. We can't predict. As written, as I also written somewhere here is,
Because at each iteration, it is returning different random numbers. That's why
no,
it is random.
yeah, this is random now, but we cannot predict the outcome. We cannot predict the outcome. Nah, you are
Yes,
not
yes,
getting.
yes,
Yes, we cannot predict the
yes.
outcome.
No,
As it is written
yeah.
here now. If we, you can see my screen is visible now.
Yes, sir, I got. Yes, sir,
If we,
it is visible. No, my question is, I got what you're saying, I got that. But
yeah,
my question is whether we can predict so that we can achieve some level of security identification.
I
I
have taken
know that it is different. Always it is producing different, and
yes.
it is yes.
So, and that algorithm, now suppose it's fine, okay. We discuss here two algorithm, LCG and PBS, okay, fine. And in the case of LCG, okay, I'm setting a range 1 to 32. Fine. If somehow, am I audible now? Hello?
Yes, sir, audible. Yes, sir, audible.
Yeah. So I am what? I am assigning our range 1 to 32. Okay. So I know that okay, my n is 1 and my last value is 32. Is it okay? And for that particular case, I also know like what I'll get, what value I will get, because the setted range is very small. Like I want a numbers between 1 to 32. That's it. That's okay. Okay. So fine. Okay. In that case, we know we are getting the only 4 or 5 random numbers. But if I want to generate a random numbers 1 to n, then what will happen? Do you think it is predictable? We can predict if my 30, instead of 32, I'm using n.
No, not predictable.
So like I'm not, if it's making me confused, like why I'm not getting your question, like what is the need of getting the predictions of number, like what is the need, what is the
Because
advantage?
my question is depending on the random number generation, on
Yeah.
those numbers we are applying the cryptography algorithm.
Yes.
Okay. In most of the algorithms, we are first considering generating the random numbers, and over those random numbers, we are applying the cryptography algorithm. Okay. So whether we can predict or the attacker can predict those random numbers so that it can breach the security. My question is that.
Sir, by using these algorithms, no one can predict the number of algorithms. But if attackers want to predict that particular numbers, generated numbers, they have to use other algorithms. Have you heard about
Yes, yes.
yeah, they have to use another algorithms by using this, this cryptographic algorithm. Yeah.
Okay, thank you.
Yes. So, okay, this is all from my side, and I think I'm able to explain you two algorithms that are very important for pseudo random random number generator generation. And this slide I will share with the ma'am. Okay. And these are the basic characteristics of PRNG. That is basic thing like efficient, deterministic,